Hello, this is Bill again. This is the second video in the IT Fundamentals series that I'll be doing. This is the first one with actual content for the exam. So from here on out, all videos will discuss the content for the exam, not just study tips and the book, etc. So we'll just start with here. Again, this is the CompTIA IT Fundamentals ITF Plus exam. This is the first video. This covers Chapter 1 of our book. And if you see the intro video, you'll see the book that we're using. It's the all-in-one guide for this particular course. Chapter 1 is computer basics. This is just the very, very basics of computers, and then we'll get into more hardware, software, and other topics in chapters 2, 3, and beyond. So it kind of this chapter jumps over all over the place a little bit, but it's not a bad chapter as an introduction. So we start with how people use computers. Most computers have a human interface, such as a keyboard, monitor. We use mouses for those, and the personal computers, laptops, phones, and tablets. Again, they have that computer. They're designed for people to use. There's a second class of computer systems that are known as the Internet of Things. These don't have a direct human interface, they're used for monitoring things like security cameras, baby monitors, thermostats. Your Amazon Echoes, Google Homes, your internet toaster, internet refrigerator, that type of thing. They're not designed to have a human touching and feeling them all the time. They're just simply there doing their job, and then you interface with them using one of those other types of devices, a phone, a tablet, or a laptop. So when you hear the term IoT or Internet of Things, we're talking, again, a computer that just doesn't have that direct human interface. There are 4 common things that all computers have in terms of hardware. This varies a little bit from your book, but this is kind of a generic description of what they are. The first is a central processing unit, the CPU or processor. This is the brains of a computer system. It determines what hardware functionality you're going to have, how much memory you can directly access. It, by and large, determines the speed of the what's called the bus, and this generally directly impacts the speed of the computer itself. The CPU controls all processes within the computer itself. So if you want to print something, you might say Control P on your keyboard, but that's going to go to the processor, and the processor is going to direct that output to the printer for this class. So the CPU is, again, the central processing. It does all processing in the computer. It does all decision making within the computer. Your input device is how to get data into the computer. Most commonly, keyboards, mice, could be a touch screen on a phone or a tablet. It might be a network interface card. It could be some kind of a sensor, a temperature sensor. An output device, how to get data out of a computer, a monitor, your monitor on your tablet, a printer. So again, how do we get data out of the computer system? Again, it doesn't necessarily also have to be something human readable. It can be a network interface card that's sending data to another computer. And last, we have storage. Storage, there are 3 types of storage we'll get into later, but the 2 most common that we're going to talk about are memory, RAM memory, which is a scratch pad. That's for all your data processing is done. It's volatile. In other words, it's not permanent, so when you reboot your computer, that RAM memory disappears. It can be easily overwritten in the system. The second is permanent or semi-permanent storage. These are your hard drives. So again, they survive a reboot, but at the same time they can be overwritten. Along with those those 4 pieces of hardware, we have 3 pieces of software. I'm going to the middle one here to begin with, is the operating system. The operating system gives us our overall feature set of the computer, how it looks, what it's capable of, what apps it's capable of running. So that's your operating system. It is the one that kind of sits there. It's the piece that you see most. So like on an iPhone or an Android phone, how the icons look, how the icons react. On your Windows operating system, you can click and drag, what you double click on. If you look at Filer, what your folders look like, what your disk drive looks like, that's all governed by your operating system. It also governs what apps you can have. So, can you run, certain word processors. For example, you cannot run a word processor designed for the Macintosh OS on a Windows machine. It just won't work. So, the third piece of software we have is our firmware or device drivers. This is a piece of software that sits between our hardware and our operating system and provides the interface to our hardware. The operating system, again, is a piece of software, but it needs to know how to talk to that hardware, and our firmware and device drivers provide that interface. So for the operating system. So your applications speak to the operating system, your operating system speaks to the firmware, and the firmware is that provides that interface for the hardware. As an example of our basic computing device, we have an Apple iPhone. And this as easily could have been a Windows workstation or a Linux workstation or a Macintosh. But the hardware contains the CPU. This is, again, for our computing and processing. Storage. We're going to have some kind of a some RAM memory in there, along with permanent memory that will store our data and our music. Our software is the iOS operating system, Apple's iOS operating system. This gives us our icons and the capabilities of the phone. FaceTime is an app that we can use for communications. And our data is our music and photos. Data is not really software, but had to put it somewhere. Common computing devices. The one thing about here, for this exam, it's more important to know the names of these things. The only one you're going to really ever probably see, at least early in your career, unless you're working in a very specialized industry, are servers. So these are multi-user computers. That means more than one person will access them at the same time, not on a directly attached keyboard and a monitor, but through other computers that will access these. So we have servers. A server is designed to serve out or share other pieces of hardware or applications. So you may have a file server where we store files. Everyone in the company can store files in a central location. We may have an application server or a web server. Again, the web servers serve out web pages to other computers and other computing devices. Mainframes, mini computers, and supercomputers. If you just kind of know that these exist, you probably should be okay for this exam. Mainframes are very large computers. Banks, government agencies use them. Mini computers, smaller, and supercomputers, those are the ones that really do all of our artificial intelligence type things. But if you just kind of know those names, you'll probably be okay for this exam. The servers we'll cover servers in more detail later. And second, we have dedicated computers. These are designed to be used by one person at a time. Our laptops and desktops, smartphones and tablets. When we connect two computers together so they can share data and communicate with each other, we call that a network. Networks can be used as share storage, share resources such as printers, or share applications. They can also share data, which would be a resource. Networks can be wired. In a wired network, you're going to have a say a laptop, is going to have a wire running from the laptop to a central device. That central device is called a switch. Excuse me. And all computers that are on this wired network will have a wire running from the computer to at least one, maybe multiple switches. And the switches might be connected to themselves, to other switches. In a wireless environment, we have a device, maybe a phone, it could be a laptop, it could be a desktop, that has a wireless card in there, which is basically a radio that communicates to a wireless access point, which is a radio receiver and transmitter, usually in a ceiling somewhere. It could be on someone's desk, but usually mounted in a ceiling. And all these devices connect to this wireless access point, wherever that access point would be located, or multiple access points. And that's how communication is established wirelessly. And then we have a combination of, most common app networks are a combination of wired and wireless technology. Local area networks are networks that are designed to be in a single location, such as a house, an office, it might be in a school building, or it could be in an entire campus for, say, a larger corporation or a university. A wide area network is a network that connects two or more local area networks together. And when we connect these local area networks together, we use devices that are called routers. And these routers allow us to transmit between the two local area networks. A special device that we use in our small office, home office devices, small office and home offices, or SOHO, get used to these terms, LAN, WAN, SOHO, small office, home office, is a small network. Usually we have these in our homes or very, very small offices, and it'll combine a router for internet connectivity, a switch, and a wireless access point. So this is kind of what a local area network looks like. A bunch of computers connected to a switch and maybe a shared printer out here. So again, they can all connect and communicate with each other. A wide area network is going to take two local area networks and connect them together with some routers. And along with that, we're going to use a leased circuit. Those leased circuits are circuits that we go to somewhere like AT&T or Verizon, whoever our local telephone company provider is, and who has wire or enough cable coming to our location. And then we will lease that on a monthly basis or an annual basis. We'll install our routers that allow us that communication from our LAN to the subscriber network or the leased circuit, and then we'll install that router at both locations of the local area networks, and they will communicate using the router. Routers can communicate through telephone lines, DSL or digital subscriber lines, cable TV, and special dedicated circuits like ISDN T1 and T3. A small office, home office, again, has all these three devices combined. So we have our router, which has both a wired and a wireless connection. And we have devices like might be a phone, a voice, IP phone that can connect to the router, a printer, multifunction machine, a PC. They may connect via wired. We might have a wireless phone, a couple tablets, maybe a smartphone that connect wirelessly to this router, and this router will connect us to the internet using through, say, a cable modem or a DSL circuit. Now, servers are designed and built to serve specific roles. Common roles, we have our database servers. So a database server is a server that has just a bunch of data on it with some specialized software. Imagine you're running a store and you have to have an inventory of the stuff you're selling. You'd have a database that has all the information about all the products in your store, the SKUs, the product descriptions, the price, maybe the price that you paid for it along with the price you sell it for, the quantity you have, on hand, maybe the quantity of orders you have. It just contains everything in this database. You may have a database of customers if you're an online store where you're going to ship these. And these database servers are just capable of taking all this data and serving it out to your applications and your web servers. And you can take that data, you can query it, you can sort it, you can analyze it. The second type of server we have is a web server. A web server is a server that serves out web pages. So, you go to www.cnn.com and you can get to the news or whatever is going to be served out by cnn.com. And you use a browser such as Firefox, Chrome, Safari to get to that web server. You can view what's being displayed on that web server through the browser. Application servers are a little bit different. They're similar to web servers in that they serve out content, but they don't serve it out to a web browser. They serve it out to an app. So, you might have the Facebook app on your phone. That Facebook app talks to a Facebook web server, a Facebook application server, and you can now, that's how they communicate. Facebook still has a web server along that you can use if you want to use a browser, but you can also use the app. A file server is a server where we're storing a bunch of data that we want to share. So you're in a company, maybe you're, you and your coworkers want to share files, spreadsheets, databases, pictures, graphic images. You would put those in a central location, and all of you could access those files and modify the files, view the files, save files, and without having to transfer, these files via email or some other way. It's just one central location. Everyone can get to it and modify those files. A print server is exactly what it sounds like. It's a server that will allow us to consolidate printing to a single device or multiple printers. The better print servers allow not just printing, but they allow us to rewind print jobs. So we'll say print job is printing, something crashes in the print job, maybe a paper jam. You could clear the paper jam, rewind the print job, and print from where the jam occurred, or reprint the whole thing. A client is a device that could be your phone, a laptop that connects to a server. So your phone that is running the mail app, when you connect to Gmail, that your phone is the client, Gmail is the application server. Operating systems are the foundation of our computer, and they manage all of our the software resources on our computer. So operating system defines how the system screens look, what our icons look. Do we have icons? There might be a command line system, which we'll talk about just a bit. So how does that look? How's the computer used? Can data be shared, or is it standalone? How do the apps access resources such as hardware and software? Yes, they use drivers, but can they access all hardware? Can they access all software? So that's your operating system defines how that occurs, and then what programs can do when they're running. So, can a program access a printer? Can a program access certain parts of memory or hard drives? Your operating system determines that. Some of our common operating systems on PCs are the Mac OS, Linux, Windows is the most common operating system, and on phones we have Apple's iOS or Google's Android. So operating systems can be described as a graphical user interface or command line interface. Right now, our GUI or graphical user interface is the most common interface seen today. However, some of these GUIs do allow access to a command line interface to perform tasks. So if you look off to the right here, we can double click on those, and we see what's happening here based on pictures. At the bottom is a command line interface, and this is just a quick list of files in a directory that we have on, in this case, the C drive of a computer system. So with a command line entry, you're presented with a prompt, and you have to type the command to display or to run the program you want. So for example, on this one, ls is stands for I think list, and it just shows a list of the data and in this hard drive. Software licensing, there are two types of software licensing, commercial and open source. Commercial software is owned by a company that makes it. So Microsoft owns Windows, Microsoft owns Office or Microsoft 365. Apple owns the Mac OS. Some company out there owns Minecraft. You can purchase the software, you can use it, but you can't modify it. You're limited to what the system is designed to do. Open source software is free. You can download it. Along with downloading it, you can download what is called the source code. This is the program that's used to write that application. And if you want to make changes to the application, you can make those changes and republish that application. So you're free to make those changes as desired and as knowledge permits. Some common open source software is Linux. That's an operating system very similar to Windows. As a description, not in their capabilities. Firefox is a browser, an open source browser. OpenOffice is a word processor, spreadsheet, presentation piece of software, very similar to Microsoft 365. And Boss Wars is an open source game. Mobile computing devices are devices that are designed to be taken with you and be small. Phones, tablets, and e-readers. Mobile computing do have their own operating systems, and the most common ones are Apple's iOS and Google's Android. Two others are Microsoft's Windows Mobile and BlackBerry. You will probably never see Windows Mobile or BlackBerry in your career. You will see Apple and Android. So applications or apps. So I use those two terms interchangeably. So our local apps are programs designed to run on a local computer. These apps can be downloaded and installed on the device and don't require a network connection or an internet connection to operate. A mobile app is a program that's designed to be run on a smartphone or tablet. These apps are purchased and downloaded from an online store like your Apple Store, your Google Store, and installed on the device. They may or may not need an internet connection to operate. Streaming media is music or video that's downloading from the internet and playing while it's downloading. This file is not stored on your device, and an internet connection is required to use streaming media. Web apps, they reside on an internet server in the cloud, and the system's browser runs the app directly. Gmail and Google Docs are examples of web apps. You access them with your browser or some app. Data stored out there in the cloud. They're running, and your browser is basically the application that is running the app. In a cloud computing, the apps are generally accessed and stored online in the cloud and not on your local computer. A lot of cloud applications are collaborative in nature, and this allows multiple people to work simultaneously on the same file and see the changes in real time. So you can have two people accessing the same spreadsheet, for example, and when one person makes a change in the data on the spreadsheet, it's reflected in real time to the other person running the who's looking at that app. We're down to the final couple slides. Virtualization. Most computers run a single operating system, such as Windows, Mac OS, or Linux, and it runs that application on the system, and that's it. In a virtualized system, we have a single computer that runs multiple operating systems at the same time. The virtualized systems allow us to share hard drives, memory, RAM memory, hard disk, processors, and network interface cards on a single machine. But it is actually running you can actually run multiple operating systems. In a virtual operating system, there's an application called a hypervisor that allows us to share these multiple operating systems on a single piece of hardware. The hypervisor allows the virtual machines, and that's what they're called. You can have 3 copies of Windows running on, say, one machine, and they are 3 independent copies of Windows running, sharing memory, CPU, network, and disk space. There are 2 types of hypervisors, type 1 and a type 2. In a type 1 hypervisor, the operating system is the hypervisor. It's designed to share all the hardware resources among the virtual machines. Microsoft Windows Server and VMware's ESXi are examples of hypervisors. A Type 2 hypervisor has an operating system such as Windows or Linux, and then the hypervisor is an app that runs and manages the other operating systems you're going to run on the system. So a Type 2 hypervisor, they include Microsoft's Virtual PC, Oracle's VirtualBox, VMware Workstation, and VMware's Fusion. Specialized computers that have a single task that you should be aware of for the ITF Plus exam. A point-of-sale system is used by retail stores. They combine a cash register with the ability to process credit and debit cards. Your automatic teller machine, used by banks, provides 24-hour banking information and the ability to do some banking transactions, such as deposit money, withdraw money. Global positioning systems allows for accurate navigation. Think of Google Maps, Apple Maps. Voice over IP, or VoIP, VoIP. More advanced versions are called telepresence, are a way to make not just a phone call over a network, and that includes the internet. It also gives you the ability to have a virtual conference to a computer or smartphone, so you can have some people on laptops, some people on phones, some people on tablets in a virtual conference. The telepresence also has the additional capability of allowing virtual capabilities such as a collaborative whiteboards. That's it for this chapter 1. We'll have chapters 2 and 3 coming out in the next several days. So just be on the lookout for these systems.